So today I'll be delivering a lecture on the dynamic web, and this I guess forms the core of what this unit's all about. So up until this point, any of the web units that you've done in this course, you'll most likely have been focusing on creating static websites, HTML files with CSS. So today we're going to look at what is the dynamic web, and probably more importantly, why we need it. So I'm going to address the second part, why we need it, first, and then I'll talk about what it is and how we use it. So I like to do that by starting with a little bit of a review of the history of the internet, where it came from, how we've got to where we are today, and where in all likelihood it's going to be going in the future. So the internet, as if you want to try and pin down the internet as an invention, it's actually quite a difficult thing to do, because it's not necessarily like one single person came up with the invention of the internet. It's sort of the culmination of a lot of different technologies from a lot of different areas that have come and combined together to form what it is that we know as the internet and the World Wide Web today. And I think that makes it really interesting. It's one of the most broad cross-disciplinary endeavors that's sort of ever been undertaken. And you can break down, I guess, what goes into making up the internet into a few different categories. So you could talk about the physical internet, and when we say that, we mean basically the network infrastructure that carries the information. So your cables, your data exchanges, your data centers, the computers, the web servers, all of the hardware that goes into transmitting all of this information around the world between networks. Then you could look at the logical side of the internet in terms of how information is organized and transported. So when we look at that, what we're really sort of talking about there is the World Wide Web. And the World Wide Web and the internet as terms tend to get used interchangeably a lot. And that's kind of fine, but I guess the way I will sort of differentiate them here is when I talk about the internet, I'm talking about the hardware, the network infrastructure. When I'm talking about the World Wide Web, I'm talking about the sort of the software and network protocols that sit on top of that, which logically control the flow of information around the hardware. Okay, so we've got those two: the physical, the logical. And then we've got the two areas which, as web designers, visual designers, interactive designers, is probably where you're going to concern yourself with the most. So we've got the representational, how we represent the data, and in our case that's usually visually, in terms of a web page and then whatever content goes on that web page, text, graphics, videos, whatever, however else we want to represent that raw data that gets sent across the networks. And then finally the interactive, so how we actually interact with the interfaces. So your role as an interaction designer is really to sort of understand the psychology of how people are going to interact with these visual interfaces that you create, and how you can best facilitate that interaction. So, as I said, as sort of web designers and interactive designers, you're going to be concerning yourself with those sort of lower down areas. The first one is really the realm of sort of your electronic engineers. The logical is, I guess, the realm of your information technology people, programmers, and then as we go further down, it's more high level concepts and depending on what you like, probably, in my opinion, the more interesting stuff is actually how people end up interacting with it. But it's all interesting. So, because it's so broad, it's difficult to pick actually a starting date of where we look at when we're talking about the sort of the emergence of the internet. But as good a place as any to start is in 1958. We're the US Defense Advanced Research Projects Agency, DARPA. It's a research wing of the US Department of Defense. Did early research into what we call packet switch networks. And the reason it started off as sort of a military idea was, if you know anything about your 20th century history, this is around the time of the Cold War. Okay, and so there was a lot of paranoia, justified or otherwise, about what modern warfare might look like in a technological age. And so I guess the original intention behind this was to figure out a way of having these military installations which might be networked, and if they were networked in a traditional way, it was very easy to sever a connection between them with a physical attack on that network infrastructure. So the original idea was to figure out a way to create a kind of network that was essentially immune or at least resistant to physical attack on the network. So we could still get information through the network if a particular connection pathway is cut off. Okay, so this is just a diagram which you don't need to worry too much about, but it just represents the difference between what a packet switching network and a circuit switching network looks like. And to put it simply, the circuit switching networks, which came first, you can think of that as your sort of fixed landline phone network, and it's probably even easier to think of it as the kind of phone network that you may have seen back in old-timey days, where you actually had to ring up an operator in order for someone to physically take a cable out and connect it in and then connect you up to another person. So the idea with the circuit switching is that if you take the phone network, if I ring someone else up, then there's a particular path through that network that my phone conversation is going to take. And as soon as there's a fault in that particular connection, then my data stops flowing, my phone conversation is terminated. So the idea with packet switching is, rather than taking one specific route through the network, what we do is we get whatever data it is and we cut it up into lots and lots of little pieces, which we call packets, hence the name, and then we send them off through the network with sequencing information. And the big difference being, those packets can take whatever path through the network they need to take in order to reach their destination. They don't care as long as they reach their destination and then they're reassembled at the end. So we can be partway through a transmission of data, and if all of a sudden there's a fault in the network, it's smart enough to be able to find an alternate route through that network. So you can see there why this idea then sort of makes for a network which is more resistant to physical damage or physical attack, and hence why the military was interested in researching it. Okay, so that took a fair few years of research before they actually implemented anything, but in 1969, DARPA, or ARPA as it had then become known, created or sort of released their first version of an internet network, which they called the Opnet. So it was the world's first operational packet switching network, and it became the core network that ended up composing the global internet. So then we jump forward quite a way before we start to see, I guess, civilian interest in the network and in the internet, and that initially came from educational institutions like universities. So in 1988, the US National Science Foundation commissioned the construction of what they call the NSF-Net. And so that was a university internet backbone that connected several universities in mainland United States. And so then eventually, after it was sort of an academic curiosity thing, They did reach a point where it became something that looked like it was going to be commercially viable. It looked like your average punter was going to pay some money to use the internet. So eventually it got replaced, those networks got replaced with the ones that we essentially still have today, which are run by the usually telecommunications companies. So when was it? 1995, basically, the NSF-net was decommissioned, and what we have from then on is essentially what we have today. Large telecommunications companies who already had cables running through the ground for their phone networks, and what else, it made sense for them to be the ones to sort of maintain the physical infrastructure of the internet. And so this is a picture of a map of what the US internet backbones look like, or looked like at some point, and color-coded with various different companies. And so the only reason I show this is just to show you that there's not one sort of overarching organization in control of the physical infrastructure of the internet. It's operated by essentially companies. In Australia, we'd have the same thing. There'd be the large telecommunications companies, and then they have agreements about sharing, transmitting the network traffic between their part of the internet and other people's part of the internet. So in terms of the physical internet, not a lot has changed since then, except for sort of technology that increased bandwidth, like optical fiber, and then adding things like mobile phone towers for wireless internet and satellites and things like that. But ostensibly, that's still how the physical infrastructure works today. So that's the physical side, and now we'll start to look at the logical side. So we look at the era of around 1989 to 1990, and a gentleman called Tim Berners-Lee, who worked at CERN, which is the European Organization for Nuclear Research. He creates a proposal for what he called the World Wide Web, and he called it a proposal for an information management system that presents data in a common and consistent way. So we had the physical networks, but there wasn't a lot of consistency, or there wasn't any agreed upon standards as to how we actually transmit data and view data across these networks. So that's kind of what he did. And so you might recognize CERN as the same place where today they operate the Large Hadron Collider, and that is indeed the same place. It's essentially a particle physics research organization. So you might wonder why a guy working at an organization like that would be interested in computer networking. And it was actually a project that he kind of did in his spare time, and nearly didn't surface to see the light of day. But his idea was, if you've ever looked at any of the work that they do at places like this, they get a huge amount of data out of the experiments that they do. So he was interested in finding a way of sharing this data with other research organizations around the world in a consistent, in sort of a consistently presentable way. So that's what he came up with. He came up with the network protocols. He came up with the HTML language, hypertext transfer protocol, and he created the first web server and the first web browser. So essentially, the World Wide Web, as we know it today, is all based upon the work that this man did. Okay, okay, so on the 6th of August 1991, the first website goes online. That's a picture of the first web server, which was just a computer that was sitting in Tim Berners-Lee's office, and that's what he ran the first World Wide web server from. I've got a screenshot of the first web page ever published, okay, and it's essentially a simple HTML page. It says, "Welcome to World Wide Web," and this is what it is. So it just describes itself as a wide area hypermedia information retrieval initiative aiming to give universal access to a large universe of documents. So that doesn't actually sound like a really wide-reaching goal. So it's actually a really impressive thing that that this same technology has scaled to presenting all the kind of the information that we're used to transmitting across the internet today. So it doesn't really mention, as I say here, anything that we might associate with visual interface design. It's really interested pretty much purely in organizing, categorizing, transmitting, presenting information. Even the idea of hypertext and hyperlinks had existed before this, but this is what sort of brought it together in the World Wide Web as we know it today. And the great thing about that was could have made $1 bajillion, patenting that and making royalties off that, but decided to give it away for free. Which is probably a reason, one reason maybe it became so popular. You could argue that if he didn't do it, someone else may have, but nevertheless, that's sort of instilled this culture of open and free information within the internet and the web. Okay, so we'll jump forward a little bit to 1992 to 1995. We still see early adopters of the World Wide Web being primarily university-based scientific departments or research laboratories. There wasn't a lot of just average citizens on the web. But a turning point for this was when we started to see the web start to develop into a little bit more of a graphical interface. So a turning point was the introduction of Mosaic, a graphical browser which was released in 1993. That's a screenshot of it, and it looks very similar to any browser that you might use today. And so that's I guess you could point to that as the foundation of all web browsers that kind of exist today. So it was the first web browser to display images with inline text, and this was considered a huge thing at the time. But the important thing is the web started to become visual. So this leads to a point where visual designers, people like us, started to have a role to play in the designing of web interfaces. So we see this progression throughout where you kind of have a bit of a feedback effect. The network gets better. The software that runs the web gets better. More people use it. As more people use it, more money is injected into making it better, and then more people use it, and so you get this flow-on effect. So at this point, the bandwidth was still limited by the network technologies, but the web began to grow from a few hundred web pages. But any sense of web design was severely limited by the technological constraints. So both the browser technologies, but also the comparatively to today incredibly small bandwidths that they would have had to work with. So it didn't make much sense to send more than text, which is quite small, easy to compress data across the network. But there is a clear trend towards a more visual and a more accessible web. So as the web started to become more popularly adopted, Tim Berners-Lee saw a need to actually set up a organization which had some sort of authority to determine standards for the web, because the whole idea was to have it in some way consistent, so that information was universally able to be transmitted across it. And so rather than have a bunch of people start to make their own proprietary protocols and stuff, we had a web organization set up. So in 1994, the World Wide Web Consortium, W3C, which you've probably heard of, still exists today, was set up, the main international standards organization for the World Wide Web. Okay, and then we get towards the latter half of the 1990s, and this is when the internet started to become sort of popularly adopted. So it moved out of purely research institutions, and people were starting to connect a lot more to the internet just as general consumers of information. And when you get a lot of people, a lot of consumers starting to connect to something, then of course there's commercial interest in it. So, and then again, this is another feedback thing. So if more commercial interest in it, more money gets pumped into it, gets made better, attracts more people, and so on and so forth. And so that's how the web has kind of grown and continues to grow today. So around this time, you started to see the very first examples of, or early examples of user-created content. So rather than just having the web as sort of a library and encyclopedia of information that people could go and grab information from, you started to see people actually being able to actively contribute in creating content for the web as well. So you had sites like GeoCities, which is sadly being closed down. It was bought by Yahoo and then closed down, but it was kind of one of the first websites which allowed you to host your own personal web page. So around this time also is the period of time where you might hear talked about the browser wars. So the two major holders of the market share in terms of internet browsers at this time was Netscape with their Netscape Navigator browser and Microsoft with their Internet Explorer browser. And so they were both kind of competing for market dominance, and the way that they usually did this was to cram as many features, new features into their web browsers as they possibly could. So this is when you had a lot more visual capabilities added to the web browser. So you had things like tables and frames started to be added, support for animated GIFs. You had the addition of scripting languages like JavaScript to start adding little bits of interactivity. So this in one way was a good thing, pushed the technology forward, but in another way it was also bad because as we talked about before, there was the W3C consortium for standards. That was started to be ignored a bit because they would try and pump out as many new features as they could without necessarily waiting for them to become standards. So that was the sort of genesis of the pain that is now thankfully receding a little bit, but web designers have classically complained about having to support browsers and then having to support Internet Explorer as well. Okay, so around this time, if you can still find any archives or captures of websites from around this time, you'll see that they have a certain look, and I've got a picture of one sort of from here. Okay, that kind of thing, and we love to look at these designs and laugh and criticize, but as time goes on and I think about it more, I think it's more helpful to actually think why people made websites like that. So if you can think about it, back around this time, there wasn't a huge amount of information on the internet. The push at the time was just to be on the internet, and to be seen to be on the internet. So people's reasoning for putting a website up wasn't necessarily to create Wikipedia or YouTube or something to deliver all this useful content. It was basically to have a web presence. So you ended up having websites that looked like big, garish billboards that you'd see on the side of the highway, and that's why they end up looking like that. And of course, once everyone has a website that looks like a big, garish billboard on the side of a highway, they all start, nothing usually ends up really standing out from each other. And then once you attempt to add useful content to that, all this distracting visual imagery actually makes it more difficult to actually reach the content. So it wasn't just that everyone was crazy or on drugs in the 90s. There actually was some sort of reasoning behind why they would design a website like that. So you saw these sort of things like splash pages that didn't necessarily offer any content, um, all kinds of imagery designed to just go, hey, look at me. Things like animated GIFs, crazy background and text color combinations, text effects like scrolling marquees and marching ants and all this kind of thing. Okay, and then I've got a couple of links there if you care to go back and have a look at some of these things. So who knows? In a few years, this may actually be considered some form of art. Who knows? Okay, but the point to take from this is that point that once you start adding content to a design which is purely designed to be eye-catching, it makes it harder to actually view the content. Okay, so we jump forward to the end of the millennium, and this is when we kind of first start to see traditional interface design principles start to be seriously applied to website design. So it's always I always feel it's kind of interesting when people start to get into web design and think that a lot of it was invented with the advent of the web, but there's all of this visual design stuff that was done in print, static media for tens, hundreds, thousands of years before that. So I always say that you shouldn't ever ignore that. The fundamentals of all that stuff still really do apply to web design. It's just that you're using a different medium. But this is when the technology, the infrastructure reached a point, the level of uptake reached a point where, and the type of content that people were putting on there, where there was actually a role for an interface designer in creating web pages. And I think, as far as I'm aware, this is around about the time that this course, in its original incarnation, actually started. So you started to have web development tools like Dreamweaver, which promoted a more visual approach or workflow to web interface design. Content is becoming more important, and web design begins to focus on servicing that content. Okay, but I say here, presentation and content are still combined, specified within the HTML markup, so it's not possible to update one independent of the other. So CSS hadn't been adopted at this point. And website layouts of this period generally look square, based mostly on the use of HTML tables, which is abuse, as we know, has probably been drilled into, is an abuse of their intended use. And so the idea was you usually design a website in Photoshop, cut it up into a bunch of images, and then lay it out in an HTML table. And again, as time goes on, I again think, sure, there's no reason to do it today if there's a better way of doing it. But at this point, what if your choice is I'm going to use this thing for a reason that it wasn't intended, or I'm going to not do it at all, then what choice are you going to make? Okay, so this is a screenshot of a website called A List Apart, which is actually a really good website still today for web-related articles. And this, as you can see, you can almost pick exactly where the table divisions go in this layout. Okay, and then we reach the point of the dot-com boom and bust. So around this point is when there's a massive injection of commercial interest and funding into anything that had technology, internet.com associated with it. So everyone wanted to jump on the dot-com bandwagon, and a lot of money was thrown at people who had ideas, and no due diligence was ever really done. There's people with money got carried away, didn't understand technology, invested a lot of money in a lot of things that never went anywhere, and we ended up having a bubble and a bust. Okay, so this was a little bit of a downturn in really the first the first time there was a downturn in the development of the internet. It stalled investment and uptake in the internet a little bit, but fortunately, pretty quickly it bounced back. So then in the early part of the 2000s, this is where we see high-speed internet connectivity start to become more affordable and widely adopted. So we could throw away things like our dial-up modems and moving to constantly connected broadband. So greater bandwidth, more content, but also another important thing about that is it became the concept of being online all the time started to become more common. Before that, the internet was just something that when you needed it, you went, connected, dialed in, did what you needed to do, and then left. Okay, so there was a push towards web standards headed by the W3C, continuing trend of more content more often. A big thing that happened in this period was the standardization of CSS, okay, which I probably don't need to talk to you again about, but that allowed us to separate our content and structure with our style sheet information. So those things could be updated independently. But this is an important trend again that we will see what's happening more, and what we will continue to do more is this separation of various different parts of the design process. As the design process gets more involved, it becomes a lot easier to maintain if it's not all chucked in to the one file or to the or attributed to the one person. If we can split it up and divide the tasks amongst multiple people or multiple computers. Okay, and so this is really the time where we start to move away from static web pages towards dynamic websites, and I'll talk more to that in a moment. So this is just a screen capture of CSS Zen Garden website, which I'm sure many of you are familiar with, and it's sort of the website to demonstrate the usefulness and the power of CSS. Okay, then we go 2004 to 2007. Ish. Okay, so this is what I guess you could call the Web 2.0 era, which has all of its own design aesthetics associated with it again. But the main thing I want to focus on from this era is the push towards creating web applications versus websites. And so when I'm talking about web applications, I mean these kind of things. Okay, so there's Flickr, Wikipedia, YouTube, and Facebook there. So they're websites, but they're as opposed to sort of your flat, what I call pamphlet or brochure style websites, which is just some web pages with a bunch of information on them. They're highly interactive. They usually involve users contributing content. Lots of fast updates, lots and lots of data, and interactivity that is near or approaching that of traditional desktop or native applications. Okay, so I think I've just basically gone over those points there. Highly dynamic, community-oriented, user-contributed multimedia content, and lots of it, and highly interactive. There we go. And this is around the point where social networking takes off. Okay, so, and also purchasing goods and services online via sites like eBay and Amazon becomes mainstream to the point where it's actually now beginning to threaten, they say, traditional retailers. Okay, so we won't dwell on that too much more. Okay, and then 2008 onwards, so basically where we are now. So the trends at the moment are the continuing trends that we've been seeing all along. Faster networks, more data, more of the time, more people, more user involvement in websites. And let's see what else I got here. Oh, yeah, so the trend for content to start to find users. So rather than people going to a particular website, you subscribe to someone's Twitter feed or an RSS feed or a blog, whatever, and then that content is sort of delivered to you as the content is updated, rather than you having to go and individually visit each of those sites each time you want to see them. And that's just a symptom of having people having so much data and people still wanting to be across a lot of it. Storing personal data in the cloud, you can see a big. When I originally wrote this around about that time, that was sort of seen as maybe a future trend. But you can definitely see that now, okay, with all the cloud services that we have, YouTube, Spotify, iCloud, Gmail, okay, data is now generally, and this is a symptom of a few things, and one of those things is that there's also a trend towards accessing this data from lots of different devices. So rather than having your data on your computer and then having to go to get it, it's stored in the cloud, and by the cloud we just mean on the internet somewhere, and then you access that as you need it, when you need it, from whichever device you happen to have on you at the time. So we have things like content mashup, so combining information from a lot of different sources across the web into new interfaces, and that's something that we sort of looked at in KIB 204 last semester. And that goes with the next point. Also embedded widgets, feed services using external APIs. So recognizing that a web page may not necessarily be the only portal to the information contained on the web, but actually having APIs. So APIs stand for Application Programming Interfaces, which is just a way or a definition to allow anyone else to access the data on a website. So that's how you can write an application that goes and accesses information from someone's Facebook page or whatever other myriad of accounts that they may have across the internet. Okay, and as I said, design for multiple devices, and especially mobile. Okay, so massive push towards mobile. Okay, and there's just some examples of the kinds of things I'm talking about. So I've got Twitter there, Facebook running on a mobile phone, and behind that Google Maps, which if you remember last semester is my favorite sort of example to use in terms of a data mashup. The amount of data that it combines from so many different sources into one interface is fairly astonishing. Okay, so we're kind of up to where we are now, present day. So what are the trends that we see? We have more content, more frequently up to date and on demand, from more sources. Okay, so crowdsourcing from across different sources of data on the web, but then also from the users themselves. Okay, so a big push towards user-generated content on more devices, and in summary, moving away from a static web towards a dynamic web. Okay, and I still haven't really explained exactly what that is, but I will, I promise you. And another trend just in terms of your role as a web designer or a web developer is that you actually have to take on a lot more of these roles. So, and whether each of these roles represents one person or whether it's a smaller project, whether it's a large project and each role is a different person, or it's a smaller project and maybe one person takes on some or all of these roles. Compared to creating a website in the 1990s, with creating a website today, okay, you have to be across a lot more different areas. Okay, you have to understand a little bit. You have to understand about the physical part of the internet, and a little bit more than that, you have to understand about the logical part of it. You need some concept of programming if you're going to create dynamic websites. and then you still need your traditional visual design skills, interface design skills, and more, what's overlooked is the importance of your interaction design skills, how the people are interacting with these massive quantities of information through these interfaces. Okay, so let's now finally look at what I'm talking about when I talk about dynamic websites. So we'll discuss a little bit some of the technology. So first we have the Hypertext Transfer Protocol, HTTP, the protocol that Tim Berners-Lee came up with for standardizing the way that information is sent across the internet. And you don't need to worry too much about the technical details of any of this stuff. But this is kind of how it works. So the HTTP functions as a request-response protocol in what we call the client-server computing model. So when we say client and server, basically the server is the computer or the software running on that computer, which serves the information. So in our case, it'll be a web server, which is just somewhere where our files sit on a web server and it sends them to our computer. The client is my computer or my phone or whatever it is that I'm requesting the information from the web server on. So that's pretty much the HTTP protocol's role, is to facilitate that communication between a client computer and a server computer. And the way that works is that the client computer submits an HTTP request message. Okay, so there's a lot of information that actually goes across that you'll never actually see as part of the web page. But the client first submits an HTTP request message to the server, basically saying, hey, I need this resource, this bit of information. And then the server returns with a response message to the client containing the completion status information about the request. So in the two basic cases, whether that request is okay, yes, I have that information and yes, you can have it, or whether for some reason it's not okay, you're forbidden to access it, it doesn't exist, or various other reasons as a server, okay? And that's what you see when you end up seeing these statuses like an HTTP 404 status. That's the HTTP response, which says, I don't know what the hell you're looking for, I don't have it, doesn't exist, check the URL. Okay, and that's just sort of a diagram of how that works. So there's actually a little bit of back and forth that needs to go on between the client and server computer before you actually get the web page. And so assuming you do get an HTTP response which says, okay, yes, I've got it, here's the content, this is actually what the I guess the raw data behind the scenes of your web browser looks like that gets received when a web page gets sent to you. So it's probably too small to read, but if later on you look back at these sites, you can see there's part of this which will look familiar, which is this part in green, which is actually the HTML document, which will get rendered by the web browser. And that's actually just part of what's sent back to the client machine. That's called the response body. But as well, it gets sent a response header. And as part of this, again, you probably can't read it, but one of the first things it says up the top there is HTTP 1.0 200 OK. So that 200 is one of the response status codes, and 200 is the, yep, all good, here's the information code. And then below that, a bunch of information about the request and the server. Okay, so the reason that I show this is because, in fact, the reason I show a lot of this is attempting to dispel a lot of the concept of the magic box of the internet and what goes on. So behind the scenes, all your browser is being transmitted is a bunch of text, and it's the browser itself which reads all of this and then understands the standardized HTML markup language and then how to display that in the web browser. So you can actually make an HTTP request using command line commands and get back a web page and read it just like that if you want. It's just the way that the web browser interprets it, outputs it in a graphical interface. Okay, so this is the main diagram of the whole lecture. So finally, this is the difference between a static and a dynamic website. So a static website, which we're already used to on the left there, basically you've got at the top an internet device running a user agent being like a web browser, and it makes a HTTP request to the web server. So you can see on the left here, it's split up into the client and the server. So when it gets to the server, it first it uses the URL that you type into the browser is essentially the thing that says this is the resource that I want from this server. So it interprets that, and then on a static web page, that's pretty much what you're doing is typing in the location of an HTML file. So it very simply just goes, yep, I've got that HTML file, and then it sends back the contents of that HTML file along with the HTTP response to the web browser, and the web browser shows the page. Okay, pretty simple. So in a dynamic website, we have a similar process, and as you can see from the client side, it actually doesn't really look any different. And that's a pretty important thing to remember when we're talking about dynamic websites, or at least in this sense, server-side dynamic websites, is that all of the difference happens on the server. The browser, as far as the browser is concerned, it doesn't really care what's happening on the server. As long as it gets sent back HTML, it's happy to render that. So the difference being, we request a resource, and in this case, the resource isn't a single HTML file. What it is it usually calls a script, a bit of programming code on the server which will do something, whatever that bit of code does. But usually what that bit of code does is it will interpret the URL, and then it will, rather than having the files sitting on the web server as HTML documents, we'll usually have a database which contains the information, and then one or more scripts which is used to compile that information, and then we'll put that information together with some HTML, and then finally send the resulting output of that back to the browser as plain HTML. Okay, so we'll reiterate this when we're demonstrating things in the tutorials, but the point is, by the time it gets back to the browser, it's still just HTML. It's just the way that HTML is assembled on the server side and how the information is stored there that is actually different. Okay, so static website, as I said, each logical page is represented by a physical file on the web server. There are some advantages of static websites. Okay, and hopefully, if we're doing our job properly, as we continue on, you'll start to see more advantages of dynamic websites and less advantages of static websites. Okay, but there are some advantages. So first of all, there's a lower entry barrier for development. All you really need to know is how to write HTML and CSS. There's simpler hosting requirements because there's a lot less going on behind the scenes on the server side here, so you don't need as much software running on the server. And because of the nature of having single files, they just happen to be more easily cacheable and easier to be viewed offline. Okay, now the disadvantages of static websites is that there is, first of all, much less scope for creating a personalized, highly interactive web application. Just because without any sort of programming logic, all you can really do is present information. You can't respond to user input. I mean, you can have JavaScript, but we'll ignore that for now. That's another kind of dynamic website. But very simply, you're much more limited with how interactive you can make the website. And the other big disadvantage is that every little change or update that you need to do, you need to go into the web server, download the file, open up the file, make the change, save the file. And if that's a lot of files, if you've got 100 pages, then you need to add a new menu item, and that menu item is in every single page, then you have to make that edit 100 different times. Okay, and you've probably experienced this frustration and wondered if there's a better way, and yes, there is. Okay, and this sort of sums up why not just the disadvantages of the static website, but the fact that really there are certain websites, a lot of websites now, that you just physically could not create and maintain by creating a static website. Okay, so these stats are old now, and they'll be even more astronomical now, but whenever I compiled this slide at that time, 24 hours of video was uploaded to YouTube every minute. Every minute, a day's worth of footage was uploaded to YouTube. More than 30 billion pieces of content of all different sorts were shared each month in over 70 different languages. So imagine if you had to translate all of those. And 50 million tweets were sent per day. So just try and imagine maintaining any of those websites with that kind of volume of information coming in, and you having to manually make those changes. It wouldn't matter if you had every person on the face of the earth employed editing content on your website. It's impossible. You wouldn't get it done. Okay, so not just is it disadvantageous to use it in these cases, and as is becoming more common, it's just impossible to create a functional website that handles a lot of content and a lot of people without using dynamic web technologies. Okay. So as I say on this slide, fortunately computers are very good at automating repetitive tasks in a dynamic way. Okay, and that's essentially what we're leveraging. We're leveraging what computers are good at in order to get them to do a lot of the automated work for us. Okay, so dynamic websites. With a dynamic website, as I said before with the diagram, the web content is stored in a database and/or other external sources and assembled with markup and output by a web server script or application. The advantages of dynamic website are basically that they do all of the things that we need modern websites to do that static websites can't. Okay, so content can be updated in a decentralized way. A single webmaster does not have the sole privilege or responsibility of updating the website, and we can modularize things. Okay, so we can reuse common code. We can, as I said before in the example, rather than updating the menu across 100 different files, we can split things up and say, okay, this is going to be the menu, and we'll just insert it wherever we need it into the code, and we update the menu once, and then it gets spat out wherever that menu needs to be output in the web page. And automation. Okay, and to be fair, there are some disadvantages of building dynamic websites. The most apparent one, especially when you're starting out, is that there is more to know. You have to know more. There's a higher entry barrier learning curve for development, okay, which is the reason, even though I don't think I've created a single static website in the last 10 years, we still teach you that for the first couple of web units, because you still need to know that information, and it's easier to learn if you just ignore the other more complex stuff for a little bit. Okay, but that's not to say you have to. It's not to say you have to throw those things out. Okay, all of that stuff that you've learned is still going to be absolutely crucial and useful. There's also more complex web server requirements, again, because as we saw on the diagram, there's more stuff going on server. Okay, you have to have databases. You have to have something which interprets some sort of programming scripting language. Okay, and that combines all of that stuff together. And although it's not as much of an issue anymore, there's traditionally been issues with pages being indexed by search engines. because if there's just a bunch of files on a web server, it's quite easy to go through and just read all of the files and index the content for a search engine. It's a lot harder to do that if there's not discrete pages or files, if information is stored in databases and so forth. But we don't need to worry about that too much. Okay, but overall the benefits will almost always outweigh the disadvantages. Okay, so this is a diagram of what we call the LAMP architecture. So LAMP is an acronym which stands for Linux, Apache, MySQL, and PHP, and it's what we call a server stack. It's essentially a bunch of different programs which are required on a dynamic web server to deliver dynamic web page content. Okay, and each one sort of has a different role. So as you can see down the bottom left there, Linux is the operating system. Apache is the web server, and that's something you need even if you've got a static website. That's what does the URL detection, figures out what you want, and then sends you back the HTML. In the case of a dynamic website, we add on two more things. We add on usually a database, okay, in this case MySQL, and we add on some sort of dynamic scripting language to be able to handle the programming logic. In this case, the P standing for PHP. Now, this is not the only web server architecture there is. There's different components that you could switch in and out for all of these. But this is the most common. This is the most common web server stack for web servers in the world. Okay, so this is the one that's usually referred to. But there are others, and you can find them if you're interested in them. You may end up working with them, but it's not important. They all will essentially have one of these stacks: an operating system, a web server, a database, and some sort of scripting engine. Okay, and actually the important part of this acronym is the AMP. The Linux is really interchangeable. You can run Apache, MySQL, and PHP on pretty much any operating system, including Windows and OS X. So don't think that you have to all of a sudden go and start using Linux to develop web servers. So you can actually install an Apache, MySQL, PHP server stack on your local computer if you want. And this is actually one of the quickest ways of getting up and running with web development. If you don't already have remote web hosting somewhere, and it's pretty easy to do. I'm not going to go through it in detail, but I've given you links there to pre-compiled sets of all these components. One called MAMP, okay, M for Mac, that one for OS X, and WAMP for Windows. If you click on those links, download it. The instructions are pretty straightforward. How are we going for time here? Okay, I've probably got time just to demonstrate quickly. So let's see, hang on, I need to there we go. Okay, so this is MAMP running on my computer, and it's got a bunch of options and stuff, and which may look scary, but really it isn't. The default's usually all configured for you, but essentially what it does is it installs the Apache web server, MySQL, and PHP, the PHP engine on your computer, and then gives you a nice interface. And you could install those all individually if you want to, and if you want to do that, more power to you, go ahead. But this is a faster, easier way of getting up and started. So you usually have an interface which allows you to configure and start and stop the web server. So I've got it running, and you set up what's called hosts. Essentially, a host is akin to a website. So your default one you would usually have one is localhost, and that's generally a term that's used to describe a web server running on your local machine as opposed to on some computer at an ISP or at Google or something. Okay, so basically you need to start and run it, and then you tell it a disk location where you want it to look for your web files. So in my case, I'm using the sites folder in my user folder, and as long as this is running, I can go into a web browser and type in the name of my host, which in this case localhost. Okay, and I can get all the files and folders contained within. Okay, so for example, I've got maybe I don't. Okay, for example, I've got a copy of the exercise files here running off my local machine. Okay, so this is a web server operating on my local machine, and it gets and it's serving the HTML pages. Okay, if I couldn't see this, I really wouldn't have any way of telling whether that was running off my machine or whether it was running off a remote web server somewhere. So this is one way of running a web server locally on your own computer. Let's go back to my slides. Okay, and there's some more notes about this in the tutorial as well. But whether you end up doing that, you don't have to. I find it, and a lot of people find it, a very good way to develop, just because it's fast. You don't have to transfer all your files to a remote server each time you want to upload and test them. And so a common workflow will be to develop most of the site locally, running a local server, and then when you've done that, transfer all the files to the remote server, get it working there, and do whatever other tinkering you need to do from that point onwards. So if you wanted to look into that, you can. You don't have to. You could just do all your development on your remote server as well. So a remote server is essentially all of that same software, but running on a computer somewhere else, which you have access to via the internet. Okay, so for example, QUT has their own web server. You've probably used it for assignments in the past, and there's exists at this URL, webhost.cr.qut.edu.au. Okay, and if you go there, it gives you the information that you need to know to connect to it. So the difference between working with a local server and working with a remote server is actually very few. The major difference is how to actually get my files onto that server. When it's running on my computer, I just copy them into the folder that I said, here's my website files. If it's on another server, then I have to copy them across some other way. Okay, and we usually do that using an FTP client, File Transfer Protocol client. So again, you may have already done something like this, but essentially an FTP client is that's exactly what it's designed to do. It's designed to be like an Explorer window or a Finder window, but instead of copying files between places on your hard drive, you're copying it between your computer and a remote computer. Okay, and you usually need 3 bits of information to log into an FTP account. You need an address, an FTP address, and that's the one for QUT. If you have remote web hosting, that's something they'll give you in your setup. When you set up your account, they'll give it to you in an email, and then a username and a password. Okay, and then you can usually just drag and drop files across. Okay, now, having said that, as we already said before, we don't want you to use the QUT web server for your portfolio. Okay, and the reasoning behind that is this. So first of all, to access anything that's on the QUT web server, someone is going to need a QUT login. So if you put your portfolio there, unless you only intend to be employed by someone with a QUT login, then no one's going to be able to see it. Okay, so once you leave QUT, you're going to want to migrate your portfolio to another web server anyway. So you might go, I'll just do it now and then I'll deal with it later. But you know, avoid the hassle of having to transfer it now and just put it on an external host straight away. Also, you don't have any access. You don't actually have any access to configure anything to do with the web server. So if your website's broken because there's some PHP setting that you need to change, you can't do that on a QUT web server. And if you ask them to do it for you, they'll say no. They'll say no, they can't individually change it, and then it's a security risk, we're not going to do it. If you've got your own web server, then you can change pretty much whatever you like. Okay, and then QT's massively locked down security. There's extra hassles of actually accessing the web server if you're doing it from home outside of QUT. For example, FTPing in, you actually have to run another thing called a VPN client to actually get in there. Extra hassle. And finally, tech support. Okay, I don't know if anyone's tried to use IT services tech support here, but I can almost guarantee you'll get quicker response if you've got a hosting provider and their job is to make your hosting experience work rather than a massive organization that has all sorts of other potential technical stuff to deal with. Okay, so if that's not enough reason not to use the QUT web server, then I'm not really sure what else I can say other than you'll realize once you've done it and then change your mind. Okay, so the last part of the lecture is so these slides are quite wordy, mainly because I've copied content over from the tutorial notes, but because we've got a little bit of extra time now, I'll go over it now rather than to give us a bit more time to go over the tutorial stuff at a bit of a more relaxed pace. But don't feel like you need to frantically write this down or anything. The information's all going to be in the tutorial notes. Okay, but the process of obtaining web hosting. I think from last week, a lot of people already have their own, so this might be old news, but I'm going to go over it anyway. So basically, to obtain publicly accessible web hosting, when I say that, I mean for you to have a website that anyone on the internet can access, you need two things. You need web hosting and you need a domain name. So the web hosting is the service that provides you space on a web server for you to store your website files and serve them to the world. Okay, and really there's nothing magical about that. It's going to be a computer somewhere that's just always connected to the internet with some web server software running it and a little bit of the hard drive dedicated to you for your files. Okay, and then other than that, you need a domain name. So that's what you most likely what you call the name of your website. I mean, this is pretty common terminology now, but google.com is a domain name. qut.edu.au is a domain name, and you need to purchase a domain name as well as the web hosting. Now, quite often they're sold together, and that's fine, but you can purchase them separately as well, and then point your domain name to your web hosting. Now, this information changes all the time, so I don't. People come up to me and ask me what's a good web hosting company or domain name registrar to use, and I'll say I haven't bought either in 5 years, so I don't know. It could have changed. Your best bet is to ask around what other people have recently used, or to do your own research. So all I've really provided here is a bunch of links to places where people discuss that sort of thing. And again, it's going to be dependent on your needs as well. If you need a massive amount of bandwidth, then which I can't see why you would, but then then the right plan for you is not necessarily going to be the right plan for someone else. Okay, so there's a few links to get you started into looking at that stuff there. But having said that, a lot of them are pretty much the same. Just avoid ones that have lots of negative reviews, I guess, is my only advice. Okay, and now, so once once you've decided you want to buy some web hosting, you'll usually see that they offer various different plans for various different prices, various different hosting packages. And they cost different amounts depending on the features that you want on your web server, and then basically how heavily trafficked your site is going to be. Okay, so it costs them money to have a lot of bandwidth and a lot of storage and all this stuff. Okay, it costs them money to buy hard drives. It costs them money to have, you know, big connections, big fast connections. So the more information that you have on your site, the more storage space you need, and the more bandwidth you need. Obviously, it's going to cost them more, so it's going to cost you more. Now, I can almost guarantee that for your purposes for a portfolio website, that I would be very surprised if you need anything more than a basic plan. That really usually will suffice, and it's a good place to start anyway, because you can always, if your site becomes really popular for whatever reason, and you get a lot more people coming to a lot more bandwidth and it starts crashing, you can just upgrade to a bigger plan. So my advice is you're better off starting at the lower end and going up, rather than paying heaps for something that you don't need. So you'll see. So this is like a table of an example of a hosting provider and the different plans that they offer, and what kind of differences there are. So you can see that the price difference, and the two big things that usually determine it are going to be the amount of disk space that you need. Okay, so you can see on the lower end 200 megabytes. Unless you're planning on hosting videos or a lot of images directly on your site, that would probably suffice, and certainly I think a gigabyte would as well. But what's probably more important is one below that, the monthly data transfer. So that's how much information can be transferred to and from your website by anyone visiting it over the course of a month. Okay, so you could do some rough calculations on what you think throughout the average size of a web page, and then multiply that by how many times you think people are going to visit the site. Again, unless you start a blog or something which becomes really popular, then it's unlikely that you're going to need massive amounts of monthly bandwidth to serve your content. Okay. So now, having said that, you do need to make sure to be able to do this assignment that your web hosting has a couple of requirements, and there's only really two of them. The two requirements are that it runs PHP, okay, because as I said, there are other scripting technologies, there are other database technologies, but you need PHP, and it needs to run PHP version 5.2.4 or greater, okay, and that won't be an uncommon thing, and it needs to have a MySQL database version 5.0 or greater. Okay, so they're the requirements that WordPress, which we'll be using, needs to function. So as long as your plan's got that, and they should be included in most basic plans, then you should be good to go. Okay, all right. So once you have posted, I should just mention, I haven't written this down, but it is in the tutorial notes. You'll probably see two different classes of web hosting: Unix web hosting and Windows web hosting. In the end, if they've got PHP and MySQL, functionally it doesn't matter which one you get, but you'll probably find that the Unix hosting is cheaper, because Unix is, or if they use Linux, it's free for them to use. If it's Windows, they will have to pay a license, and then that cost will get transferred onto you. So functionally it doesn't matter, but a Unix host will probably be cheaper. Okay, so once you've purchased the web hosting, you need to know how to administer your site, how to get your files and stuff on there. And you should get sent when you register, you put your email address in, they'll send you an email that looks something like that, something like this, which has a bunch of information about, they'll give you account usernames and stuff, and URLs for how to access certain different things like the FTP address and all that sort of thing. Okay, so that should all be contained in your setup email, and there'll be help files and instructions and tech support if you need further information. Okay, now domain name registration is pretty dead simple. Again, my same advice applies. Just do a bit of research. Again, they're all pretty much the same. There's not a lot that goes on with a domain name a domain name registrar. And with both of these, I guess another piece of advice is don't think just because you're paying lots of money you're getting good value for it. The tech industry is rife with people who will charge you lots of money under the illusion that you're getting good value for it, but you know, aren't necessarily. Okay, so again, so there's a bunch of links there to point you in the direction for figuring out which one you want to use. In the end, it probably matters even less than which web host you choose. But the important thing is you will pay different amounts for different domain suffixes, or what's called top-level domains. So that's what your domain ends in. So google.com, the .com is a top-level domain. qut.edu.au.edu.au is a top-level domain. So usually your choices, you can have whatever you want now, but usually your choices are .com or .net, unless you're an organization. They're meant to stand for things, although they're abused. But your two main choices are .com and .net. You'll find that they're possibly or they generally will be different prices. .com because it's the most commonly known will cost the most, and then .net will probably be a bit cheaper. And also you'll think up a domain name. Every single word in the English language has already been registered as a domain name. So you might have trouble coming up with one that's unique. And if you don't, if there's a .com one that you can't have, you may find that there's a different top-level domain. The .net might be available, the .org or the .com.au. So just play around with that. Okay, I've got a link to a list of top-level domains here, Wikipedia article, which tells you what they're meant to be before. But again, I don't think anyone's going to prevent you from using one. I think you may need an ABM to have a .com domain. That might be the only thing. .com.au, right? Yeah. Okay, so pointing a domain name to a web server. Basically, if you've bought your domain and you're hosting from the same people, then there's nothing to do. It's already done. It will already be set up. If you purchase them separately, again, they'll send you instructions, but essentially what you do is your web hosting will have your web hosting, I always confuse this, get it around the wrong way. Your web hosting will have name servers, okay, and you put those name servers into your domain name registry account, and so it knows how to point to your web hosting site. But again, if you do it that way, there'll be instructions. But if you just want to avoid the hassle, there's nothing wrong with purchasing your domain and your hosting from the same place. Okay, so I've only got 2 more slides, so we're nearly done. And again, we'll go through this. There is more detail on this in the tutorial notes, but again, this is going back to, I said, the differences between running a web host on your local machine versus a remote host is usually the way you go about, as well as transferring files, administering settings on your website. So usually on a remote host, it will all be done through web interfaces. So in your setup email, I'll probably give you a link to a URL which gives you access to your administration interfaces. And so this is a very common one for Unix servers called cPanel, short for control panel, and you're almost guaranteed get this or something very much like it. Okay, and basically it gives you a graphical interface to go and tinker with different settings on the web server. So when I said before about putting the information in the domain name server information in and the domain name information in, this is where you do it. You go through here. So you can see down the bottom of the picture there's a section for domains, for creating domains for your website and subdomains and all that sort of thing. Most of the time you won't need to touch any of this stuff, and once it's set up you can just leave it running. But that is the interface where if you need to, you tinker with your web server. And as you get more involved in this sort of thing, you may end up using it more. But you shouldn't see it as too scary, because most of it you'll never look at. And the other thing you may use is a interface for administrating your databases. So this is a very common one again called phpMyAdmin. QUT web server has this one for creating, modifying, deleting databases. And again, it's just a web. It itself is a website which is just interfaces to allow you to administer your websites, your databases, your MySQL databases in particular. Okay, but as I said, so for all that stuff, more information in the tutorial notes. You'll also be sent. I mean, they get people registering websites who have no technical knowledge at all. So, so they will have loads of help and tech support and stuff if you need it. Okay, so that's all the slides that I've got. So in the tutorials this week, we're actually going to have a look at PHP. Now that hopefully you sort of understand a little bit about the difference between a dynamic and static website, and hopefully why we need them. We're going to look at the PHP scripting language, which is essentially our main tool which allows us to create dynamic websites, and we'll look at that in the tutorials this week. Okay, is there any questions about anything I've gone over today? No? Okay, all right, thank you for your attention, and we'll see you in the tutorials.